So the other day I got this question, how can energy be negative? And I realized it's actually quite a fun question because when you're young and you're learning the numbers, you start learning 0, 1, 2, 3, you count up. And then it's really weird when you start learning about negative numbers because they seem totally made up. They seem like a human invention. It doesn't seem like anything in reality could be negative. And it's an interesting question, how can something in reality be negative? So today I'd like to talk about negative energy. First, let's assume that you already have some intuition for what energy is like. A car moving faster has more energy than a car moving slower. This is kinetic energy, the energy of motion. Something moving faster with more mass will have more energy of motion. It takes energy to get something moving because you turn one form of energy, like gasoline or electricity, into the energy of motion or kinetic energy. If you have a car on top of a hill and the car starts rolling down the hill, you're turning gravitational potential energy into kinetic energy. So potential energy is anything with the potential to become a different form of energy. So gravitational potential energy turns into kinetic energy when a car rolls down a hill. The higher the hill is, the higher the car is, the more potential energy it has. And then at the bottom of the hill, it's lost potential energy. Its height has gone down, but it can move faster than it did at the top of the hill. So let's take for granted for now that you have some semblance that gravitational potential energy has something to do with height or distance, your distance to the center of the earth, for example. And let's take for granted that you know that kinetic energy is the energy of motion. The faster you go, the more kinetic energy you have. Now imagine some object, and it's sitting there in empty space in the middle of nowhere. And by middle of nowhere, I really mean infinitely far away from any other body. So far away that it feels zero gravity, no forces from anything else. It's really in the middle of nowhere. And it's not moving at all. So its motion is zero, its kinetic energy should be zero, and it's in the middle of nowhere. And nothing will ever happen to this particle. This particle embodies the concept of zero. Now I think you can agree that such a particle, since nothing will ever happen to it, has zero total energy. And total energy is kinetic plus potential, and we know it's not moving, so its kinetic must be zero. And so its potential energy must also be zero. And so what we found is that a particle in the middle of nowhere with nothing around it, in an absolute sense, or in perhaps the most natural, intuitive sense, should have potential energy zero. You already have the intuition that if you're at the top of a hill and you fall down to the bottom of the hill, you get closer to the center of the earth, you decrease your height, you decrease your potential energy, and you turn that potential energy into kinetic energy. From the top of the hill rolling down to the bottom of the hill, you speed up. So we have the intuition that whenever you get closer to something, like rolling closer to the center of the earth, you decrease your potential energy. But hopefully you've already agreed that this particle doing nothing in the middle of nowhere, infinitely far away from anything, has zero potential energy. And that's because it's infinitely far away from anything. But as soon as this particle is finitely far away from anything, which is closer than infinitely far away, then it must have less potential energy, because we agreed that potential energy decreases whenever you get closer. And so this is why, no matter what, the potential energy of the particle gravitationally to any other particle with positive mass will be negative. And so generally, potential energies are all negative. Now let's take for granted that energy is conserved. Total energy is conserved. You can turn kinetic into potential and vice versa, but you cannot do anything to total energy. And let's imagine a rocket on the surface of the Earth. It's not moving, so its kinetic energy is 0. And since it's on the surface of the Earth, it has some negative potential energy. And because its energy is negative, it can never become like our free particle with 0 kinetic energy infinitely far away from the Earth. So since you need to have a positive energy in order to become a free particle infinitely far away from anything else, negative energy is a sign of boundedness or binding. For example, the Earth is bound to the Sun because the Earth's total energy, kinetic plus potential, is actually negative. All of us here on Earth have negative energies because we're bound to the Earth. And the Sun is bound to the galaxy, and so forth. It turns out that most times when two things are bound together, they have a negative energy. In chemistry, for example, and this confused me a lot as a kid, chemical bonds have a negative energy. So as a kid, I remember learning that you could break weaker bonds, like carbon and hydrogen, and you could replace weaker bonds with stronger bonds, and you could release energy this way. So this is how our bodies work. We burn sugar, and we turn carbon-hydrogen bonds into carbon-oxygen bonds. So we eat sugar and we breathe out carbon dioxide. Carbon dioxide has these really powerful double bonds. And I used to think as a kid, well, doesn't it seem like you're getting something for free? You're making these powerful bonds and you're getting energy out of these molecules. How can that be? Well, it turns out that powerful bonds don't have more absolute energy. They're more negative, so their magnitude of their energy is higher, but they're actually more negative. It's as though you've dug yourself into a deeper hole. And that's what climate change is, right? That's us digging ourselves into a deeper hole. In fact, it'll take a lot of energy to break those double bonds if we want to turn carbon dioxide back into carbon. So the point being that there are multiple examples in our daily life where we see the effect of negative energy being this binding force. So negative energy has this property of being very related to things being bound together. And this is why if you want to break something apart, what you have to do is inject a lot of positive energy so that the total energy goes from negative to being positive. It's as though you have this very deep hole and you have to fill up the hole in order to get rid of the hole. So if you want to destroy something, all you have to do is fire a lot of energy at it in the form of kinetic energy or heat energy. You can try burning it, you can try smashing it, and so forth. If you want to remove something from the Earth, you have to inject a lot of energy to fuel a rocket. Anytime you have something stuck to something else, what you need is positive energy to counteract the negative energy of binding. Hopefully I've convinced you that negative energy is a natural and useful way to think about energy in the universe. Thanks.